think it's on. Oh, here. Hello, fellow Earthlings. I'm Captain Jackson Banning, Captain Jack, aboard RedLab here. The time is 09:47 on January 1st, 2035. It's not very often that you get to start the new year off by being hurled into space, but I get to. Just a little while ago we said goodbye to our friends at the International Space Station, but all I can really focus on right now is this view outside my window.
The RedLab mission is commissioned by the US and NASA, the Japan Aerospace Exploration Agency, and the European Space Agency. The mission was first conceived back in August 2020, when NASA first proposed conducting a manned mission to Mars to the US government. Recognizing the staggeringly high costs of putting together this revolutionary mission, NASA approached both the ESA and JAXA to help subsidize the funding. Now, the costs for sending people and machines into space hasn't much improved since the first missions to the moon back in the 1960s. It still costs about $9,600 per pound to launch into space. I'm talking about fuel, metal, food, liquid oxygen supplies, human flesh, everything. So launch alone, we're talking about $30 billion.
The total length of the trip is planned to last just under 10 months. Traveling over at a speed just about 12,000 miles per hour, RedLab is scheduled to arrive in Mars' orbit in 128 days. Now, you may notice that the spacecraft itself will be traveling unconventionally below typical space travel speeds. Even back in the 1970s, the Apollo's missions traveled at up to 25,000 miles per hour. Our new approach at slower speeds is designed to limit fuel consumption. Not only does our ship have to reach Mars, but it also has to make it back. And assuming that there won't be a fuel pump waiting for us on Mars, we have to use the same gas tank, round trip.
Aiming for both the fastest and most conservative trip, we had to plan the voyage to take place between the closest points of opposition between the orbits of Earth and Mars. On September 11th this year, 4 months before RedLab is scheduled to land on Mars, these two planets will be at the closest distance during Mars' retrograde motion, a mere 35.4 million miles. This is the closest these two planets will be to one another in the next few decades, so it's important that we take advantage of this opportunity now. This timing will allow RedLab to reach Mars, conduct approximately 2 months of research, and head back on another 4-month trip, arriving just in time to catch Earth on its closest encounter with Mars. RedLab will only be traveling at about 12,000 miles per hour, but Earth will be traveling around the Sun at about 67,000 miles per hour. This mission has to be impeccably timed to ensure that the spacecraft is not left behind in the wake of Earth's orbit.
This is Captain Jack Banning. It is day 4 on RedLab. As you can see, I'm feeling pretty sick. No amount of training could have really prepared me for this 24/7 experience of weightlessness. Though I am feeling a lot better than I did for the previous 2 days, I'm still pretty prone to a bit of motion sickness. It's particularly bad when I'm trying to conduct experiments on board the spacecraft, the system checks. I didn't really expect that the weightlessness would affect my vision, but it's getting really hard to try to adjust to this new environment. On top of this, I'm feeling space sick. It sounds similar, but it's much worse than being seasick. So, on the shuttle, my eyes can tell which way is up and down. I can still orient myself, but even though my eyes know direction, the vestibular system within my inner ear requires the pull of gravity to detect this, and then sends those messages to my brain. Since gravity essentially doesn't exist up here, the messages of up and down that my brain receives don't make any sense, resulting in nausea and this constant disorientation. Here, try to imagine yourself on a roller coaster. When you get to the top of the track, the roller coaster dives downward. You get this feeling where your stomach is still left up at the top. Well, in space, you get that feeling constantly, for several days. Fortunately, my brain is supposed to adapt to only register visual signals of up and down, and I'll start to feel better soon. In the meantime, I'm still feeling pretty sick, so I'm wearing a NASA medication patch to help with it.
It's a common misconception that there's no gravity in space. When orbiting Earth, gravity is still pulling on you, but your greater distance from Earth means that its force of gravity is slightly weaker. The more distant two objects are, the weaker their gravity pull on each other. So in space, it's technically more accurate to refer to the feeling of weightlessness as microgravity.
Now on Earth, gravity pulls on your blood, causing significant volumes to pool in the veins of your legs. Now once you encounter microgravity, the blood shifts from your legs into your chest and head. Your face tends to get puffy and your sinuses swell. This fluid shift also shrinks the size of your legs. This bloated face and your sinuses will feel congested, which may contribute to headaches, as well as space motion sickness. You feel the same way on Earth when you bend over or stand upside down because blood rushes to your head. These effects will remain for the entirety of the trip. However, one starts to adjust to the feeling after several days.
I'm feeling a lot better, but I'm still not that hungry. Eating is such a strange sensation. When I swallow food, it doesn't ever really feel like it hits my stomach. Everything just kind of floats inside there. So you can imagine why I've lost my appetite. I'm still trying to stay on my meal schedule, but I am losing weight. It is easier to stay hydrated than it is nourished, though. What kid doesn't like Capri Suns? If you want to eat and drink everything out of little small packages, become an astronaut.
When you are in microgravity, your body adopts a fetal position. You crouch slightly with your arms and legs half bent in front of you. In this position, you do not use many of your muscles, particularly those muscles that help you stand and maintain posture. As your stay on a shuttle lengthens, your muscles change. The mass of your muscles decreases, which contributes to the bird-leg appearance, meaning that your legs become thinner from the loss of muscle tissue. Your muscles adjust, becoming thinner and quicker for moving around the shuttle cabin. It's a completely different muscle type that your body starts to develop. Ultimately, the longer you stay on the shuttle in space, the less muscle mass you will have. This represents a problem for long-duration space flights.
So in addition to muscle change, there's also a bone transformation. In Earth, your bones support the weight of your body, but in microgravity, your bones do not need to support this weight. So all of your bones, especially the ones in your thighs, hips, and lower back, recognize this change and begin to stop calcifying them, determining that you no longer need to use them in this environment. The result is that the size and mass of these bones continues to decrease and is greatly reduced at about a rate of 1% per month. These changes in bone mass make your bones very weak and brittle and very likely to break upon your return to gravity. Now, this change is always a consideration that limits the duration of space flights. That is why we implement a regimented high-tension workout routine for astronauts that must follow on a daily basis. Exercise is the best countermeasure to these effects. Now another countermeasure to deal with fluid loss is a device called lower body negative pressure. This applies a vacuum cleaner-like suction below your waist to keep fluids down your legs. Captain Banning will have to spend about 30 minutes per day in the lower body negative pressure to keep his circulatory system near Earth condition to help reduce muscle loss.
About a week ago, I started to really be able to see Mars pretty well from my window, but nothing has compared with the view that I have today. Over the next 2 days, the shuttle will make its way to Mars, but I'll spend about a week in orbit before making the descent to the surface. it's gonna feel pretty good being back on land. I don't know how Polyakov did it.
Spending a little over 4 months in space isn't any small task, but it doesn't even begin to compare with the more than 14 months Polyakov spent on one trip in the Mir space station. Our entire trip won't even last that long.
Right now, I'm getting ready to go on my first walk on Mars. I've been on the RedLab shuttle for 146 days, and I can't wait to get some fresh Martian air outside. We landed on Mars just south of its northern polar ice cap. This is where my main research will be focused. But research is going to have to wait until tomorrow. Today, I will be training myself to adjust to Mars's low gravity environment.
Mars has two polar ice caps in the north and south. Its northern polar ice cap is comprised of carbon dioxide ice, not frozen water. At its south pole, the polar ice cap is completely dry ice. Now, due to Mars's extreme temperature shifts from 20 to 30 degrees Celsius in the day to below 140 degrees Celsius, the ice does not melt and evaporate, but sublimes, turning directly from ice to gas. Now, at one point, Mars did have rivers and lakes of running water, but they disappeared from the planet.
We hope to discover why all of Mars' liquid vanished, in order to determine if it could happen on Earth, and what would need to be done to stop it, if possible. Captain Banning's research at and around the polar caps will reveal a lot about the planet's conditions and the potential existence of previous life.
Landing on Mars a few days ago, I've been trying to adjust to this gravity. I feel pretty bouncy, but I'm definitely wobbly and uncoordinated. I hope to get my senses back over the next few days.
Mars's gravity is 0.379 that of Earth's, a little over 1/3, meaning Captain Banning, who weighs 170 pounds here, will only weigh a little over 70 pounds on Mars, suit included. While his bone and muscle density will begin to return from what mass he lost in microgravity, it will not return to the strength he had on Earth, because it's not necessary on Mars' surface.
The low gravity of Mars will be only one environmental hardship that Captain Banning will have to overcome. For instance, Mars' harsh landscape is scathed with dust storms, carved with canals, canyons forming impassable barriers for any travel. Luckily, RedLab is landing during Mars' summer season, so Captain Banning will not have to deal with the planet's frigid winter when the polar ice caps begin to reform and spreading down to the middle latitudes of the planet.
The majority of the work is done back in the shuttle's onboard lab. I'm able to conduct experiments here in just a minute, which would have taken the rovers weeks to coordinate. My research is focused around analyzing various types of Martian surface samples. Mainly, I'm trying to look back in time in Mars's history to find details about previous water and life on the planet. If we can learn more about what it was like and why it disappeared, it might give us some really important insight into our future on Earth.
There was incredible opposition proposing a manned mission to Mars.
Mainly, that is too dangerous. There were certain physical constraints in preparing for this mission. Could the astronauts cope with the physical toll in lower gravity? Could our shuttle launch out of Mars's orbit? Could we even conduct a mission in 10 months and not miss our opportunity to return home?
Now, what could a manned mission to Mars accomplish that a machine could not? We've been arranging efforts to study Mars with rovers and probes for over 3 decades, and the biggest issue is communication and coordination. It takes weeks to conduct a simple experiment. Our robots, no matter how advanced, do not have the spontaneity and thought process that a human has. Scientists, on the other hand, can respond much more flexibly and intelligibly to new or unexpected encounters. Our astronauts will double 30 years of research in just 2 months.
There's always the criticism. Why invest money in space when there's still problems on Earth?
When we figure out one problem, another will always arise. But we need this challenge to bring us all together, to be proud of, to dream about. We need to have the foresight that what we're doing is for our future.
This is day 201 now, here on RedLab. And this is the final day before heading home. I'm happy to know that what I've done here will provide some profound answers for everyone on Earth today and in the future. But I am just really excited to finally get back home and continue my research there.
Ascent propulsion system, forward EVA hatch, RCS thrusters, attitude control. Repeat, attitude control check. This is RedLab to Houston. I have a master alarm and attitude control. Please confirm.
Houston to RedLab, roger that. We confirm the master alarm on attitude control. Perform system check for dynamic positioning.
RedLab to Houston. All systems are go, but attitude control is still failing. I will wait for the motion reference report. Please confirm.
The attitude control sensor, that is, the device that models and tracks the vehicle's orientation, kind of like a GPS, was not properly picking up the signal from its radar. It may have been just a single sensor, but successful navigation on a return trip relies on the accuracy of this sensor.
Houston to RedLab, the master alarm on attitude control is airing on red. We cannot clear you for takeoff, Captain Banning. We repeat, the master alarm on attitude control is airing on red. We cannot clear you for takeoff. Dynamic positioning is faulting too much for launch. Please confirm.
Due to the alignment of Earth and Mars during their close encounter, there is only a short window of time during which it is possible to travel between the two planets. Unfortunately for the RedLab mission, mechanical faults prevented us from following the mission schedule. The next close encounter between the orbits of Mars and Earth is in November 2037, when the planets are 46 million miles away, 10 million miles over the trip to Mars.
Now, of course, precautions have been made to ensure Captain Banning's safety and comfort in this time. Like on the International Space Station, RedLab has life support systems that recycle oxygen for the air supply, purifies and recycles water and waste, and the shuttle's loaded with dehydrated food reserves for at least 1,000 days. So Captain Banning is all set for the next 20 months on Mars. I suppose the positive side of this incident is that the extended research that can be done.
I just finished fixing the attitude control sensor today.
Attitude control check.
I have just spent the past 27 days in this cabin, waiting for a dust storm to pass. Even though Mars has a gravity environment, it's still very low compared to Earth's. I still have to rigorously exercise every day to keep up my strength. But it's still having a big toll on me physically. I feel weak and sore most of the time.
Unlike Earth, Mars lacks a thick atmosphere and a magnetic field. This leaves the planet totally vulnerable to radiation from space. Studies conducted before this mission present that living on Earth results in 20% chance of cancer. On Mars, the increased radiation is predicted to increase that chance to 40%. That's why it's necessary to limit any outside exposure to a minimum.
However, this poses another possibility of psychological problems such as claustrophobia, isolation, and insomnia. Confining one's movement to the boundaries of only a narrow metal 30-foot tube can be an immense mental and emotional strain.
been really hard to communicate so far with NASA. I don't know if this video log is getting through anymore, but it might be. I'm hoping that I'm going to get some sort of confirmation in the future how it's working out.
The entire RedLab station on Mars is powered by solar energy. This poses problems since Mars' surface is covered in dirt. The frequent windstorms kick up miles and miles of dust, and this dust absorbs solar radiation in the planet's atmosphere, which partially blocks the transmission of solar energy to the Martian surface. Now, RedLab is designed to power down processes that aren't vital for survival, to preserve energy for those critical systems. However, we've lost communication with RedLab, and communication is one of those critical systems.